Hey there, awesome physics students. Let's talk about mass and weight. To start, let's imagine an object that's in free fall here. And what are the forces on it when it's in free fall? Well, in free fall, the only force acting is gravity, which is the weight. Okay, I use Fg, but you can use W. It doesn't matter very much. And we know under this circumstance that the acceleration is down at g. Okay, and if we use a standard xy coordinate system, then our force, if we sum our forces in the y direction, then this would give us Fg down. That's in the negative y direction. So I put a negative sign there. And then I set that equal to ma in the y direction. But I already know that my acceleration in the y direction is g down, which according to our coordinate system is negative g. And so this becomes negative mg. Fg, negative Fg is equal to negative mg. Or in other words, Fg is equal to mg. Okay. Now this is true. This is true, of course, in free fall, but this is also true if the object is just sitting on the ground and is subject to a normal force. The object doesn't, gravity doesn't care whether it's in free fall or it's sitting on the ground. The force is going to be the same. It's mg, even if the acceleration is not g in this case. So I think it's best to think of, now remember that g does not mean gravity. G is just a number. G is positive 9.8, and we used to use it as an acceleration in meters per second per second. And that's useful in this situation where it's in free fall and the acceleration is actually g because that means something. But in this situation, it does not mean the acceleration is g down because it's not. And so I think it's better to use the following units, that is the units of newtons per kilogram. And the way you interpret this in this situation is that the Earth is attracting you with a force that's proportional to your mass, and the way to convert mass into weight is by multiplying by this conversion factor. This converts kilograms into newtons. Okay, so you can imagine if you take the mass and multiply it by something that has units of newtons per kilogram, the kilograms are going to cancel and you're going to be left with newtons. All right, so this is the value that we're going to use, or the sort of equation we're going to use for weight. But please don't think that the acceleration is g down in all situations. It really is not. Instead, think of g as a conversion factor.